Welcome everybody to today's webinar by the IEA SHC Solar Academy. Please hold the line and we will begin shortly. Welcome everybody to today's webinar. Please hold the line and we will begin in a minute. All right. Thank you everybody for joining us today for this webinar by the IEA SHC Solar Academy. My name is Arabella. I work with the team of the International Solar Energy Society, ISIS, based here in Freiburg, Germany, and I will give you a short introduction into the work that we do. We are hosting the event for the IEA SHC, and then you will hear their presentations. So today's topic is by the IEA SHC Solar Academy series, and it's on the global market data of the solar industry, and they will present key insights from the Solar Heat Worldwide 2025 report. Before we get started, a quick word into ISIS. ISIS is the International Solar Energy Society. We have been founded in 1954, so we've been around quite some time, and we have individual and corporate members from countries all around the world. And in addition, in the very early 1990s, we also got accredited by the United Nations. Our vision is 100% renewable energy for all, used efficiently and wisely. And as part of our mission, we present a huge range of key activities, and you will probably have heard of some of them. We have 2 congresses that we put on rotating schedules. This year it's going to be the ISIS Solar World Congress, which is going to take place in Brazil, actually just the week around COP. So that's going to be an interesting event. And then next year we will be having the Eurosun 2026, and that is actually in cooperation with the IEA SHC team as well. We host webinars, the ones like the ones you're seeing today. We have education initiatives for young people, both online and offline. We have an entire solar energy museum that hosts 60+ years of solar research and history. We provide infographics, and we have 2 flagship publications, the ISIS Solar Energy Journal, which has also been around since the 1950s, and then now, in addition, our fully open access Solar Energy Advances Journal. Now, before we head into the webinar, a quick word on the Q&A session. You will hear the presentations by the different speakers, and we will have one cumulative Q&A session at the end. So we will not be taking questions in between, but rather all in once at the end. The way to submit your question is through the chat box, which you can see on your little Zoom icon tab. You type in your question, and then our moderator, Christoph, is going to distribute the questions to the presenters. And with that, it is my pleasure already to introduce our moderator of today to you. It's Christoph Brunner, and he is the CEO of IEA INTEC based in Austria. And at the IEA INTEC, he focuses on energy and research efficiency, as well as the integration of renewable energy solutions in industrial applications. Christoph will be introducing us to the work of the IEA SHC, and he will be guiding us through the webinar, and he will also moderate the Q&A session for you at the end. So, the floor is yours, Christoph. Take us away.
Yeah, thank you very much, Bella, and welcome everybody. I will directly share my screen and start with a short. So, hope you can see my screen.
Yes, if you put it in presenter mode.
Yeah, just a moment.
No worries.
So okay, good. Yeah. Welcome everybody. I think to this very interesting webinar today. It's about the solar market, and just to give you an overview in which framework it is developed and all the statistics are collected. It's within the solar heating and cooling IEA technology program. This is a program of the International Energy Agency, and Within this program, there's a focus on R&D collaboration since 1977. We have about 20 member countries and plus the European Commission as a strong member of this collaboration, and also additional 9 international organizations. You can see it here on this world map. Mainly these organizations are situated in Africa. Within this program, more than 200 experts are running in or give their expertise and knowledge to 7 running tasks. And the topics of these running tasks you can see here. It's about PVT, solar district heating. It's also about integrated lighting systems, solar hot water technologies, life cycle analysis, new direction on solar photoreactors to produce fuels, sun fuels, and also on compact energy storage. What is this Solar Academy? In which framework this webinar is going on? It's a platform of the solar heating and cooling program, and it is installed to share and to apply these findings and experiences out of these different tasks, since this running tasks, but also past tasks. These tasks, they are producing results, highly scientific results, and these are training materials, these are case studies, fact sheets, databases, but also assessment tools, evaluations, and designs. The webinars are held quarterly, and as you know, as what Arabella also mentioned, hosted by ISIS. The next webinar will be in October 2025. It's on solar hot water for 2020-30, results out of the task 69. All the tasks, all the webinars started at 2 GMT on Tuesdays, and there's a rebroadcasting and with live Q&A sessions at 6 GMT, always on Thursdays in the same week. The webinar is recorded, and you find previous webinars on our website of IEA SHC under this link seen in this presentation. Besides the webinars, the Solar Academy also is organizing on-site training, so the on-site dissemination activities. In the past, we had trainings in China, Cape Verde, also in United Kingdom, and also in Southern Africa. And the next on-site training will be in Johannesburg in South Africa, from the 18th to 22nd August 2020, and the topic will be solar energy for industrial applications in the SADC region. More information you will find on the website following the link here. Also the different publications, just feel free to download it here, and also you can follow us on LinkedIn and YouTube. And if you have any questions, here's the email address of the Secretariat, and for sure you will get answers immediately when you send here an answer to them. Our flagship report is the Solar Heat Worldwide. This is the topic today. Already with the new edition, it is published or released today, so really hot and brand new. And I'm really looking forward to this webinar. These are the speakers. I'm happy to introduce you then step by step to our 4 different speakers, starting with Monica Spörk-Dürr. She is employee at IETEC, and she will give you a first overview of the solar market trends in a nutshell. Monica studied plastic engineering at the Montan University Leoben in Austria, and she's working at IETEC since 2010 with a special focus on solar thermal energy, resource efficiency, scientific disseminations, and solar thermal market analysis. Exactly this Solar Heat Worldwide report. She's doing it. She's a lot active in southern region of Africa with the Solgen project. and she has experience further to cover the monitoring of energy efficient houses as well of solar thermal systems. So Monica, we are really looking forward to your presentation, and yeah, the floor is yours. Please start and take over. I will stop.
Thank you very much, Christoph. I will share my screen. So can you see my screen?
Not yet.
Not yet.
Yes, yeah, now.
Okay.
Just to move it in present. Yeah,
yes.
Perfect. Good. Thank you.
Well, thank you very much, Christoph, for the introduction. I'm really honored to present some of the key findings of the Solar Heat Worldwide report at this webinar. First, I would like to give a short overview of what the report contains. So there's data from 73 countries considered, and I would like to thank all our country partners and authors of the special chapters who contributed to the report. Without their support, this report would not be possible in such a detail as it has. The collector technologies that are covered are water collectors, both unglazed and glazed, evacuated tube collectors and flat plate collectors, air collectors, PVT collectors, and photovoltaic generated heat. The applications covered are small scale that still has the main market share for domestic hot water and space heating. There's a second topic about large-scale applications for hospitals, for district heating, for sports centers, and the tourism sector, covering applications and systems larger than 500 square meters. Another focus is on industrial applications, and we will hear later in this webinar about industrial applications in more detail presented by Bärbel Epp. And there's another chapter about applications in the air conditioning and the cooling sector. The overall figures for 2024, 544 gigawatt are installed and installation and in operation with an energy yield of 443 terawatt hours. That corresponds to 153.5 million tons of CO2 equivalent emissions reduction. And that shows that solar thermal contributes a lot to decarbonizing the energy sector. That just one moment. The employment and the turnover in 2023, the employment was about 318,000 jobs and a turnover of 13.9 billion euros. That corresponds to 15.7 billion US dollars. The development of the global solar thermal capacity in operation and annual energy yields between 2000 and 2024 shows an immense, huge increase. So starting from about 15 gigawatt thermal, 60 gigawatt thermal in 2000 and reaching 544 gigawatts in 2024, like mentioned before. This capacity corresponds to 770 million square meters of installed collector area in operation.
Monica, there is just one comment. Can you please click on Ausblenden, then we can see the full slide. Yeah, thank you.
The annual installed capacity between 2000 and 2024 shows that was a peak in 2013, and the development was mainly driven by the Chinese markets, and I will show a slide later on that explains this in more detail. But here I would just like to show that in 2024, 17.8 gigawatt thermal were added as a collector areas. And that means a decrease over the past decade. But compared to 2001, it nearly doubled the installed capacity, yearly installed. This slide shows a comparison of the different renewable energy technologies. The three main technologies are photovoltaic with an installed capacity of 2,247 gigawatt installed in 2024. And wind power is second with 1,136 gigawatt installed. And third is solar thermal heat with 544 gigawatt installed. Green hydrogen, geothermal power, and solar thermal power take only small shares. But I would also like to emphasize that with the aim of 100% renewables, all technologies are important and needed to reach this aim. The market development, as mentioned before in more detail, here you see the market development with regards to the development in China and Europe and the rest of the world. You see that between 2000 and 2011, there were two-digit growth rates. And since 2013, the market decreased, mainly because of the markets in China. And the market decrease in 2023 was 8% compared to 2022. The market in Europe also saw declines, but remained comparatively stable. Besides Europe and China, there are developing markets, especially in other Asian countries. Depicted in blue, the blue line on this slide. That's mainly driven by the market in India, and also Latin American markets see increase. The markets in Latin America are mainly Brazil, Mexico, Chile, and Argentina. The African countries, so like sub-Saharan African countries, depicted in orange here, are also increasing and overtook markets in Australia in 2022. Countries with the largest market growth in 2024 are Mexico, Brazil, Turkey, and Cyprus. So Mexico saw a market increase of 14%, Brazil reported 11% market growth, and Turkey 10% market growth. And Cyprus, the market increase was 2%. The market increase was mainly due to the building sector's development, but also some regulations in place in the different countries. In the next few slides, I would like to show a few highlights of the report. One of the highlights are large-scale installations for district heating and large-scale buildings like for hospitals, sports centers, tourism sector. The picture shows the largest system that was commissioned in 2024. It was installed in Groningen in the Netherlands and feeds into the district heating system of Groningen. It has a collector area of 48,800 square meters. And the solar heat costs range from 20 euros to 50 euros per megawatt hours. And that means that for such large-scale systems, the heat costs are competitive with other energy sources. This slide shows large-scale solar thermal heating systems, the development over the years. There was a high in between 2019 and 2021 with about with over 50 systems reported. And in total, there are 622 systems with a collector area of 3.4 million square meters and 2.4 gigawatts in operation. And that means an increase of 4.1% compared to 2023. The district heating sector takes the largest share of large-scale solar thermal heating systems. Two countries are dominating this sector, so Denmark and China. Denmark has installed 124 systems with a capacity of 1.1 gigawatt. And China has installed 76 systems with a collector capacity of about 0.5 gigawatt. In total, 346 solar district heating systems are in place with a collector area of 2.8 million square meters and 2 gigawatt thermal. There's another focus on solar heat for industrial processes. As mentioned before, I would only like to show 2 slides because Bärbel will go into detail here later on. There are about 100 systems were added in 2024, and the main collector types are parabolic trough and flat plate collectors. And the main applications are mining, food and beverage, and other processing industries. A couple of these systems, so a large proportion of these systems, are also documented on the SHIP database that is run by IEA Intec, and that is used for the analysis of the solar heat for industrial processes in the report. The top 3 countries are Mexico with 139 systems installed, the Netherlands with 83 systems installed, and China with 70 systems installed. There's also a breakdown with regard to collector areas and sector analysis in the report, and it's worth to have a look at this. An interesting development is photovoltaic thermal collector areas that that have increased after 2 years of decline, and 13% of increase was reported in 2024, and the total installed collector area with regard to PVT is 1.7 million square meter installed worldwide with an installed capacity of 864 megawatt thermal and 315 megawatt electrical. Photovoltaic generated heat is an emerging technology that is mainly reported from South Africa and Australia, but data is still very scarce. But in future, it would be interesting to have more data available for this sector, as it seems to be an increasing market. A study has been done in the South African market from Stellenbosch University that shows that over the last years, the market increased, and in 2023, about 34,000 installed systems were reported. with this, I would like to come to my last slide, and I would like to emphasize that the large potential for solar technologies is still there. So the renewables supplied only about 10% of global heat in 2023. There are proven technologies and emerging technologies that could contribute to solar heating and cooling for decarbonizing the buildings and the industries. Small-scale systems for buildings in markets like Latin America, Asia, and Africa will still remain an important sector. And large-scale systems for district heating and process heat are in the pipeline in different countries, as, for example, in Germany, China, or for example, in Germany or in China, but also in other European countries. Solar cooling options could help to reduce cooling-related carbon emissions by 60% by 2050. And cooling will become more important over the next years because of climate change, and there are possibilities for both photovoltaic and thermal-driven cooling options in place. Last but not least, research and development will continue to play an important role, reaching from advancements with regards to small-scale systems, materials development, control strategies for reliable and cost-efficient systems. But there's also research going on with building integrated, prefabricated solutions for net zero energy buildings, and increasing the performance of advanced technologies like PVT. Another topic for research and development that will be important is thermal energy storage. They will play an important role to use the full potential for grid flexibilities with regard to sector coupling, and it will be supported by intelligent control systems. And there will also be new systems and new topics where research and development will be important. For example, solar fuels or photovoltaic catalytic solar reactors. The overall aim will be to reach 100% renewables in the heating and cooling sector. And all the technologies mentioned in this presentation and detailed in the report will be necessary and important to reach this aim. So thank you very much for your attention, and you can download the report from the website with the link depicted here. Thank you very much.
Thank you. Thank you very much, Monica. Fine. So we have already some questions in the Q&A, but as Arabella said, we will answer them after all the presentations. I'm coming now to the next presenter. It's a minute. So you see my screen? So then,
yes.
Yeah. So next presenter already seen also live. It's Bärbel Epp from Solrico, Germany. Bärbel, she is the founder and managing director of the German consultancy Solrico. She is responsible for the international newsletter of the web portal solarthermalworld.org and reporting exclusively about the market and technologies trends in the solar heating and cooling sector. And Solrico also created the first online world map of SHIP suppliers. SHIP stands for Solar Heat for Industrial Processes, and carries out service among the around 70 companies listed on this world map annually. And Bärbel, she is also graduate in physics and at the University of Oldenburg in Germany. And you see already one of the topics she's working on is SHIP. And also today we will hear this specific market and innovation and outlook trends of SHIP, solar heat for industrial processes, out of this market report. So, Bärbel, thank you very much. And I will stop now sharing my screen, and you can share now your screen, and the floor is yours, and we are looking forward to your presentation.
Perfect. Thank you, Christoph. I hope my presentation is visible.
Yeah, perfect. Now it's good.
Okay,
Goodbye.
good. Yeah, thank you. Good afternoon, everybody. My topic today is solar industrial heat, markets, innovation, and outlook. These are the key figures from the report and from the survey we carried out annually. 120 megawatt were newly installed SHIP technology in 2024. Christoph already introduced SHIP will be the shortcome of my presentation. It's solar heat for industrial processes, so please get used to this short form. It's a 28% increase from the previous year. We see a dynamism in the SHIP market, also by noting that 125 megawatt of SHIP capacity were under construction by year's end. So there will be also an increase this year. Another key figure is the 69% of new SHIP capacity uses concentrating collectors. This was a bit of a special feature of the year 2024 because we saw a big installation with 80 megawatt installed in China for leisure park in snowmaking. And this is seen on the photo in the circle here. And this brought us a big market increase and also this high share of concentrating collectors. If you look now into where the SHIP capacity of the year 2024 was installed, you see that it's a worldwide phenomenon. We have China very dominating the market, but Germany also did well in last year's survey. We have also a lot of other countries see SHIP capacity installed, and I only would like to highlight the trend that Latin America here also looks prospering. We have seen new installations in Cuba, Colombia, Ecuador, Panama, and Brazil. This corresponds also a bit with the dynamism we see on the general market development on this continent. Well, you see here, this is the world map that Christoph already mentioned. We have established this world map of SHIP turnkey system suppliers in 2017, and ever since we do annual surveys. We have currently 66 companies listed, and from the pie chart on the right, you see that they offer a big variety of collector technologies. So you have the very high temperature parabolic draft and linear Fresnel solutions, but you see also low temperature solutions like air heating or PVT. Even we have 5 PVT manufacturers listed on the world map, and they once in a while also install industrial solutions. From the surveys, we identified the top SHIP suppliers. Here in terms of the total SHIP capacity they have installed so far, which must be above 7 megawatt to be listed on the map. 15 companies are listed here on 3 different continents. You see Mexico, USA, some countries in Europe, and China. I have marked here the 5 companies among the 15 which offer concentrating solutions. And this is GlassPoint in the USA, Inventive Power in Mexico. We have Solitherm in Germany, Aztec Energy in Belgium, and Vicot in China. And the ones which are underlined in purple here are the ones which concentrate on solar heat contracts instead of selling hardware. So this is a big important issue as well, that we have companies really concentrating on selling heat contracts. How was the mood of the SHIP suppliers about their business development last year? We have asked this question over several years, and unfortunately, the rather negative trend continued last year in terms of that not even every 5th company has been satisfied with the business development. So what are the reasons that the companies gave us in the survey? First, slow decision-making processes in industrial clients, then the challenges to meet payback expectations and heat cost requirements, the short payback periods which are usually expected from the industry cause problems. Then conventional energy in several countries are still far too cheap. And there is a lack of trust into this rather new technology by industrial clients. There was one quotation that I would like to share with you, which summarizes a bit the atmosphere as a whole, which says, although we have many leads in various countries, we have not closed any project during 2024. That means that there is high demand, the companies receive a lot of requests and do a lot of pre-visibility studies, but to sign a contract and to get the deal done is still quite challenging and often takes longer than expected. And this leads me to my next trend, the strong fluctuation among ship turnkey suppliers on the world map. We have seen again some companies that we had to remove from the map because of bankruptcies and closure of business. We had 3 of them. It was Heliovis in Austria, Heliac in Denmark, and Calido in Spain, all in concentrating solar collector field. We have seen 2 companies that continued business after an insolvency. This was one by Tigi Solar Israel, acquired a 90% stake of Solid Solar Energy Systems in Austria out of an insolvency of Solid, which was one case. And the other case was that Aztec Energy at the beginning of the year, 2025, was newly founded and purchased assets from the then insolvent Aztec Group Belgium and hopefully continues some of their leads. But at the same time, we see new entries and new companies being listed on the world map. And this were in this year's survey, 6 companies, and they also lead the way towards new markets. So we have Elianto, a linear Fresnel manufacturer with first demonstrators from Italy. We have Neo Energy from Panama, a project developer which did some smaller systems recently, like egg washing and some agricultural businesses. We have Master Solar in Serbia, a flat plate collector manufacturer. Actually, they did some well-known brand systems like for Coca-Cola, PepsiCo, and Yasaki. We have H Solar, a newly started flat plate collector manufacturer in Mexico. Mexico is generally a dynamically developing market and is the strongest ship market worldwide. So they also want to get into the field of project development. Autonomize from Austria is a particular founded company to develop ship projects. This is also a new trend that we see, project developers focusing on commercial solar heat. And we have Synhelion, newly listed from Switzerland, a developer of solar towers for fuel production. And this leads me to my next slide on innovations that we have reported, that was reported from ship turnkey suppliers. This first photo shows the solar tower with this reactor for the fuel production of Synhelion. It's based in the north of Germany. It's a demonstrator project, but under more or less permanent production of fuels with 1,500 degree at the tower top. We have GlassPoint among our companies listed on the world map, and they have this photo shows the 2nd generation of their enclosed parabolic draft technology, which is like covered by a foil construction, not anymore a glass greenhouse as before. And they mentioned in the newsletter that they are using molten salt as heat transfer medium and storage, and this will reduce capex by 20%. Actually, the key feature of the parabolic draft system is that it's very light, and therefore the receiver stays fixed and is not shifting together with the whole mirror as in normally large construction. So this is a special feature of if you enclose your parabolic. And then a few more short notices on innovations. We have TVP Solar from Switzerland working on a solution for low pressure steam production within the collector, which is now commercially available. They have we have Flemming Jorgensen from Mexico. They developed a control system for large solar mining projects. They have a service contract on a mining project which has 900 square meter in Mexico since 2024, and there they established this control system. And we have cost reduction measures for installation work developed by Phoenix Solar Thermal from Canada, and they are working in cooperation with Upsolicon Sweden. Yeah, this was it regarding the current market situation, and now we look into the future. We have developed the Solar Industrial Heat Outlook, and this is the second version of it, covering the years 2025 to 2027. This was possible because the project developers were very cooperative and we had a great willingness to cooperate in the sense of opening their portfolio and giving us their leads and their projects under development. We had altogether 73 projects reported by 29 companies. And you see the overall development now here. This is a cumulated chart on the ship world market since 2016 without China, because the world outlook we established without China because the figures from China are rather not so transparent and not so consistent. So what we see here is that we have at the end of 2024, we had around 75 megawatt, 750, megawatt installed with around 1,200 projects, which is the gray dot on the top of the chart. And there will be now added 277 megawatt in these 73 projects, and this is a weighted capacity. And what means weighted here? That projects which are in the early phase of planning are only calculated with a third or 2/3 of their capacity, because there might be still something happening that the project will not be realized. So if there's a pre-visibility going on, it's 30% of their capacity that is calculated for the outlook, and only if there's a contract signed and if there is a construction has started, then we count it as 100%. So this chart shows you where about these 277 megawatt will be installed, and you see that Chile will reach the highest share of this amount because we have 3 mining projects already under contract. Even construction has started with 154 megawatt installed in Chile alone. And the second important region here is Southern Europe with 23 projects and 63 megawatt. But you see ship projects also on other continents, Middle East, Australia, we have one announced project. South America is included. Asia, Mexico, Turkey are traditionally strong markets. Turkey will come up now with some more projects. So it's an interesting all around the world business, we can say. Yes, as part of this outlook, we have heard and reported about big investments and high subsidy allocations that I would like to list for you here particularly. The one I have already mentioned is by the Chilean power utility Gasco. They will invest $71 million in these 3 flat plate collector fields and run them as an ESCO for the 2 copper mines, Minera Escondida and Spence. In Canada, the project developer Solar Steam received grant agreement for 2.8 million Canadian dollars from the government of Alberta. This will be their first demonstration project and one of the largest ever on concentrating technology in Canada. They are using also enclosed parabolic draft collector technology, and it will be for water treatment of a factory. Tigi Solar from Israel started a cooperation with EN Group from France to develop ship projects under ESCO projects with up to a volume of 40 million euro. So they have a bit budget available now and big investment grants available now. Not grants, equity available now. ClassPoint from the USA announced just last week a big installation with 750 megawatt in California, and they already received a tax credit allocation in December last year, which covers US dollar 168 million. So this will be used by ClassPoint because this is again an ESCO project, and it's part of the American Recovery and Reinvestment Act. And the last one on the list is the Australian Renewable Energy Agency. They allocated 17 million Australian dollars for an 18 megawatt parabolic draft collector field that should be installed at Mars Petcare facility in California, in Australia, Victoria. This is a factory that should be carbon free within the next couple of years. So it's a very strict internal carbon reduction target that the company has. So you see that there is big investments and big grants also available in this market all around the world. Well, one last short trend that I already mentioned several times now here in figures that concerns the heat delivery contracts, or ESCO, like energy service contracts that we observe. You see the last 3 years, also again, new addition without China, and you see the share of ESCO among the newly installed capacity, which was changing from year to year. It was between 0.4 and 63%, but it will now raise to 90% of the new 277 megawatt that we identified in the outlook. So we see that the outlook, the large installations within the outlook are clearly SHIP, and this business model more and more establishes on the industry market, industrial solar heat market. And this is my last slide, where we will have a short look into which industrial sectors will see the new installations that are part of the outlook. And you see here the same sectors that Monica already mentioned. Food is by far the dominating market because they have a lot of applications and usually lower temperatures up to 150 degrees. But also agricultural and animal breeding is a big share here. Chemical, pharmaceutical, and beverage are traditionally already in the past, but also in the future markets which are prospering for SHIP. So this was it from my side. I would like to stress the fact that the charts of the Solar Industrial Heat Outlook are available for download at this link, and you are very welcome to use them in your presentations. They are made to be spread, and they have general sayings, you know, and they are all marked with references, so you can use them very easily. And the results of the SHIP survey, you find them on solarthermalworld.org, and you can also follow us with a newsletter if you want to be updated regularly. Thank you very much. And I'm looking forward to the Q&A.
Yeah, thank you so much, Barbara. Very interesting. And yeah, already several questions in the Q&A. Yeah, looking forward to this discussion later. Coming now to our next presenter. Right. Just a moment. Yeah, you can see my screen, hopefully. So yeah, our next presenter is coming from Zimbabwe. It's Professor Samson Malanga. Samson is Associated Professor in the Department of Industrial and Manufacturing Engineering at the National University of Science and Technology, as well as the Country Coordinator of Soltran Projects in Zimbabwe. And he is member of the Soltran Project since 2012. Samson holds an MS Master of Science in Advanced Manufacturing Systems and Industrial Engineering. And so he has over 20 years of engineering education and engineering consulting experience. He has experience also in system modeling in simulation, engineering optimization, renewable energy, of course, with focus on solar thermal technology. He's member of the Zimbabwe Institute of Engineers since 1996, and he has worked on over 150 industrial-based projects as postgraduate and undergraduate level, focusing on optimization, including solar thermal cooling, heating, and drying. And additional, Samson, he is a trainer of the solar thermal installers. So Samson, we are really looking forward to your presentation. It will be about the thermosiphon systems in Southern Africa. It will be insights from the IEA SHC Task 69. And yeah, I will stop sharing my screen. And if you share your screen and if we see then your presentation, the floor is yours. And we are looking forward to your presentation. You have unmute you. And then, yeah, we see your screen already. Presenter mode, maybe would be nice.
Thank you, Christoph. Thank you, colleagues. Good afternoon. My presentation this afternoon is thermosiphon systems in Southern Africa, insight from IEA Task 69. On the left, you have my presentation. I'll basically give you a quick overview in terms of the systems design as classified in Task 69. And then I'll give you a brief market survey and application areas. And part of the work in Task 69 in thermosiphon systems, where we looked at the failure mode defect analysis of systems within Southern Africa. We also just give a snippet on issues to do with quality and standards, and then also give you the best practices and case studies before I conclude. On the right, I've just given you an overview, picture in terms of global horizontal irradiation over Southern Africa, Sub-Saharan Africa, to see the great potential that we have. Below it, we are sitting with 9.8 million square meters with 406 million inhabitants, which is close to about 5% of the world population. We're looking at the bottom there from an extract from SAP, which is basically the Southern African power pool, showing that it's got an installed generation capacity of 80 gigawatts with a peak demand of 57 gigawatts, but with an available capacity of 48 gigawatts, showing the deficit and the great potential in demand side management through solar thermal, in particular thermosiphon systems. We realize from the reports that have been given that more than half of the total installations worldwide are basically thermosiphon. We know overshadowed by the great installations in China, but within Southern Africa, it's also the same kind of scenario. Here, just a brief introduction in terms of the systems design that we looked at in Southern Africa, where we realized that we have direct thermosiphon systems, which are common in our region due to low risk in terms of freezing. In some countries, yes, we have countries like Lesotho and sometimes in other areas in South Africa where we get freezing during our winter times. Below is just showing you the configurations as in terms of the direct thermosiphon system and indirect thermosiphon systems. This was the first task that was undertaken within Task 69 to be able to classify the different thermosiphon systems into direct and indirect systems. And you realize that indirect systems could have different kind of configuration as shown in the slide. These obviously are represented either as evacuated tube systems or flat plate systems within the region as shown in those two slides, in those two pictures in the slide. In the task 69 was undertaken, just extracts, I just did just a few extracts as in terms of the market survey that was undertaken, where we looked at the manufacturers and assemblers within the region, where we realized that the major of them are focusing on solar collectors from the responses that we got, and followed up by mounting systems, followed up by storage tanks within the region. Within the survey, we also looked at the number of produced models, and the models were broken into mainly indirect evacuated systems or indirect flat plate systems, or direct evacuated systems, or direct flat plates systems. We also looked at the sizes in terms of the text of the systems that were being installed within the region, where we looked and realized that 150-liter tanks were basically the majority, as in terms of storage tanks that were being installed within the region. We also looked at what was the requirement or the end user requirements from the Southern African region, where we realized that durability and reliability topped as an issue of concern within the market. And we also realized that warranties, where people wanted at least a guarantee in terms of the durability and the lifespan of these systems, was of concern within the region. The rest were basically following up issues to do with low price, as well as maintenance and easy to operate and install. In terms of improvements, that information that we got through the survey, we realized that making the system easy to install and operate came top, as in terms of an area of concern of improvement, followed up by innovations in terms of being able to sell energy than just installations. The other issues that were of concern was of standards and product certification, followed up by improved durability and reliability. So I'll continue my presentation just to show you a few slides in terms of area of application within the region. One of them is mass housing. These are examples of mass housing installations that were done in Namibia under one of the projects in the region, Soul Train, where we also participate, where we had like 62 solar thermal systems installed. These are flat plates supported by the project Soul Train. These are within the 10,000 housing development systems in Namibia. Some of these installations were supported also by a project. Within an area of application of hotels, hospitals, and clinics, we had installations in Zimbabwe on the Marondera Maternity Clinic, supported also by the projects, besides other private installed systems within the hospital and clinic sector. Within the education sector, we had installations in Harare, 22 square meters installations for thermal siphon systems with storages of 1,500 liters. We had installations in Namibia of 28 thermal siphon systems, just to show you examples of application in education sector. We had also some installations in Lesotho, showing you evacuated tube systems installed, supported within the projects. Then we also had some installations in Zimbabwe at Roosevelt Girls High in Harare, just showing evacuated tube systems. We have also had installations in hotels in Botswana, as shown within the slides, where we have 5 distributed thermosiphon systems on top of that hotel. With those examples within the region, the task went forward into looking into failure mode effect analysis to realize that there is need to support the technology for there to be a great uptake in the future and trust from the clientele. So a survey was also undertaken within the region that looked at the different failure modes and effects that were realized in the systems that were installed. We tabulated them. These were leakages due to components failure, improper systems dimensioning, incorrect mounting support, wrong positioning of pipes, wrong positioning of vacuum breakers, leakages due to wrong installations, missing insulation, deterioration of insulation due to missing protection, missing and wrong positioning of safety devices. We also realized other failures that were noticed in the systems were leakages due to missing or wrong concentration in terms of antifreeze liquid. We also realized the wrong responses in terms of pressure from the safety valves, missing inspection of antifreeze liquid. We also realized corrosion on the tanks, and also these poor water quality, especially for the systems that are using direct systems where the water that is being used goes through the collector side. Based on these failure modes, we went forward onto looking at the possible cause of those failure modes and possible causes and suggestions in terms of technical solutions that were given. So we also documented proper installations and the guidance as in terms of avoiding these failure modes so as to support the technology within the market. Supported behind all this was basically the issue to do with standard and certification. It was also documented where 3 of the Southern African countries had national standards, Zimbabwe, South Africa, Namibia, just to name a few. And then we also documented this quality concerns that were being taken care of by some of the projects in terms of installations, looking at the certification, like the KeyMark certification schemes being used, especially for installers to ensure that the systems are of high quality. Supporting this was basically dual training within Southern African region to support quality installations. These were done in Mozambique, Zimbabwe, Namibia, Botswana, just to name a few countries within Southern African region. Training also were undertaken, as I've mentioned, in these 6 countries since 2009, and extension of trainings have been commenced to cover areas and countries like Malawi, Swaziland, Zambia, Tanzania, Angola. And within the task 69 is also planned for thermosiphon training aimed for in September 2025 in Windhoek, Namibia. From all those installations, we, as a task, targeted also to document best practice examples, and 1 or 2 of the examples that will be basically documented. Example from Zimbabwe, from the Convent of Lady Kingsdale. And others will be documented and will be shared in the near future. And these are some of just examples in terms of pictorial views of best practice installations that have been done, pulled from Zimbabwe. Well, one in this is in Harare, 7 times 300 liter direct thermosiphon systems, individually mounted on individual housing units. And then we have 13 times 200 liter thermosiphon systems installed in Mary Park in Harare. In conclusion, I would say based on the high radiance in the Southern African region, the population and the drive by the region to meet domestic needs of energy supply by demand-side management and energy efficiency, there's great potential to be tapped by both local and international partners through solar thermosiphon systems. Just extending my acknowledgements to the different partners that we have worked with in providing and supporting Task 69. Thank you very much.
Yes, thank you, Zanton. Thank you very much for this very interesting presentation and these insights of the results of the task. Yeah, can we already some additional questions, but we'll have another presenter before we go to the Q&A session. And this presenter is, can I just share my screen? Yeah, it's Valérie Séjourné. Valérie, she is, she had a background in communication marketing, and she started her career in several companies like Danone or Unilever as a communication officer and at the French Energy Transition Agency in ADEME. She gained almost 25 years of experience in well-established pan-European association in Brussels, representing the detergent industry and leading the sustainability strategy through many initiatives and activities. She has experience in the field of corporate social responsibility, product policy, eco-design, sustainability reporting, coordinating also several sustainable consumption campaigns across Europe, and communication and stakeholder engagement and advocacy outreach towards many different audiences at European and international level. That's her passion to do this on marketing and transformation of the society towards more sustainable, low carbon, just and resilient models. And from April 2023 on, she was appointed as managing director of the association Solar Heat Europe. And Valérie, we are very happy that you are here and that you give us an outlook on the solar thermal market from the European perspective and also as a representative to the solar thermal industry. So we are looking forward to your presentation, and the floor is yours.
Good afternoon. Thank you very much, Christophe, and good morning as well to those of you who are in the other part of the world. So it's my great pleasure to present you here a couple of slides on the situation in market of the market in Europe. And indeed, we have been seeing a bit of a decline over the last 2 years, unfortunately, in the sales of solar thermal installations in Europe. When I joined Solar Heat Europe back in 2023, we were still under the effect of the aggression of Russia to Ukraine, and we were happy to report a plus 12% installation of solar thermal. Unfortunately, the momentum in people's mind did not stay, and we have been observing in 23 and again in 24 a bit of a lack of penetration of solar thermal. Why is that? It's probably due to lower investment, due to high interest rates, and a lack of of momentum on the importance for heat modernization across Europe. The fact that we also have in Europe different individual countries which have their own national policies and all different policy signals country by country on the need to exit fossil fuels and embrace decarbonization of heating has not been very helpful. We have also seen we are extremely dependent on some subvention schemes, and the fact that there would be some stop and go market effect in some countries of some of the subvention is also creating an atmosphere for people who are in need to invest of uncertainty, which has not been helpful. The fact that the gas prices fell after the 22 developments, and also the ETS carbon price for industry has also been not good, giving not good signals, for example, for industry to invest in renewable heat solutions. There is also a fierce competition among heating and cooling technologies across Europe, for example, with the heat pump, and which tends to have a bit more visibility. So this has also created a bit of different tensions and some terms of changes in the market. The fact that we have some products imported from Asia, solar PV panels, not to name them, is also, creating this competition on the rooftop space. When people need to invest in technologies, if they have the choice between some homemade, EU-made, more expensive solar heat collectors, which are one-off costs, but then you benefit from the free energy for 30 years compared to some cheaper PV panels, that has also creating some tensions. And also, yes, despite that, we have seen some growth and some further penetration of solar thermal, but at a lower pace than we would have liked. You see on the screen a map of Europe. There is a very different penetration and use on a per capita basis of solar thermal. In total, we have 41 gigawatt thermal installed in Europe. We have just done some quick calculations that if you divide Europe in three groups by geographical region, if we have some very good examples like Cyprus and Greece for Mediterranean, Austria for the central of Europe, Denmark with a lot of district heating, as Monica was explaining earlier. So if there would be some, just copying the good practice of our neighbors in Europe, we could easily move from 41 to 154 gigawatt thermal. So there is really some possibility for our region to upscale and grow in terms of solar heat adoption. We have a good political framework which was approved under the former European Commission. This is called the Fit for 55, which really aims at reaching 55 greenhouse gas emissions by 2030 compared to 1990 level. So we have here in front of you a few pieces of legislation: the Energy Efficiency Directive, Renewable Energy Directive, Energy Performance of Building Directive. At the bottom, you have also the Net Zero Industry Act, which is clearly a legislation that the European Commission and the authorities have put in place to really encourage the EU clean tech sectors to be further promoted and developed, so that Europe would have a greater number of companies producing all these different clean technologies. And in solar heat, we are really proud to be able to meet 90% of the demand of Europe with our EU companies, and really hope that they can continue to meet a growing demand. So what you see on the screen are a number of provisions in these legislations, which are now being transposed into all the 27 EU member states. So it is really critical that this EU legislation is adequately transposed into national law, and this should hopefully help steer the market. I'm thinking, for example, of efficient district heating and cooling criteria, which are showing the way of how district heating need to decarbonize until 2050. The cities have also to put some mandatory heating and cooling plans, especially only for cities above 45,000 inhabitants. There are strict, permitting, accelerator permitting criteria for renewables, and there is a solar mandate under the Energy Performance of Building Directive. I will quickly show you a slide on that, because this is really under EPBD, giving a pathway for the use of solar technologies on specific buildings by specific timings. And we have provided, you see on the right part of the slide, a guidance as Solar Heat Europe, so that member states would be really taking into account the potential of solar thermal for building in the transposition of this specific article. This is another slide showing the pathway for decarbonization of district heating. You see that the yellow bar is the one where renewable heat and solar heat in particular, just like also geothermal, for example, can and should be used in the sources for district heating. So you see that there is a clear pathway for all the district heating network to really use renewable heat sources as well as waste heat. On the other part of the slide, I wanted to advertise a bit of a publication that we have done together with different solar heat actors in the market. And with the World Business Council for Sustainable Development, this is really a good document to promote the potential of SHIP worldwide, and this is a good technology brief which is available on their website as well. So what's coming up at EU level, in addition to this transposition of legislation, which hopefully should be really supporting the sales of solar thermal and PVT, we also see that there is a strong momentum to prepare the next years ahead and the midterm. We really have a strong push at political level in Europe for a clean industrial deal to promote clean tech and EU competitiveness and affordability of energy for industry to stay in Europe, thanks to the access of affordable energy is important. So we have different communication, affordable energy action plan, affordable housing plan, and there is under preparation a heating and cooling strategy, which is due for Q1 26, which for us will also help give visibility to the important agenda of heating and cooling, where our solution can deliver a lot. So just on my last slide, I would like to also announce the fact that there is a joint industry statement, which is released today in parallel to the communication of IEA SHC and the report, which is a great piece of work by IEA SHC. So thanks from my side as well on that. So this joint industry statement is coming from Europe, from India, Mexico, Brazil, to really share the industry's perspective on these different market trends in the different regions. So I invite you to have a look at it, to read the comments of my colleagues, whom I thank as well for their contribution. Thank you very much.
Yeah, thank you very much, Valerie. Yeah, very fine, your presentation. And yeah, so now we're starting with the Q&A. I ask all the presenters to switch on the camera, please. And yeah, so we already have some questions there, and I will go through. We have about a quarter of an hour time left, so I will select some of the questions what I found here in the Q&A. So starting with one question about solar PV and which potential do you think has solar PV to replace solar thermal systems for solar water heating applications? Monica, maybe you can answer this. I know you wrote it already, but it's only visible for the person who has the question.
Yeah.
You have to
yeah. So thank you for the good question. Of course, the potential is there. So there are already systems in place displacing the solar thermal. So solar PV systems for solar hot water. But it will depend on the applications and also on the visions that are in place in general. So if there are countries, for example, for like Australia, where there is a high PV penetration already, these systems will be used in future. Probably there are also other countries that will still stick to solar thermal, like Samson already mentioned for Southern Africa. So that it depends on which applications will be focused on, and also I think there will all of the technology be important in the future, and it's not only talking about the displacement. So what will be the share of the technologies in this future? So we will need all of the technologies to reach the aim of 100% renewables in the future.
Okay, good, thank you. Yeah, then there's, because you mentioned already Samsung, there's one question to Samsung. There's, do you have any issues of scaling or fouling due to hot water in the thermosiphon systems? Can you tell us here a little bit more about this?
Thank you, Christoph. Yes, definitely there is fouling, and these are some of the failures that we have established within the systems where we are using direct thermosiphon systems in the cases of hard water, but obvious recommendations and technical systems as in terms of having softeners being installed in conjunction as in terms of the water supply is one of the solutions that has been given, and also looking closely as in terms of getting an audit before installations of these systems to say what type in terms of water quality is one of the areas that we have recommended within the TAS 69 best practices. Thank you.
Thank you very much. Yeah, maybe coming to Beaver, there's some question on SHIP. The first question is also related to Africa. Looking at the world map, I realized that Africa, most importantly South Africa, does not feature any SHIP projects. What could be the main reason for such a lack of demand of SHIP, despite all the indicators pointed at the market here?
Yeah, well, this is always a reason answer, you know. It's not straightforward. I think in South Africa, and we can give this question maybe to Samson afterwards, I would say that it's a mix of having still relatively cheap fossil fuels, and then a strongly increasing PV market. So we go into what Valerie said, you know, rooftops are used with PV a lot. And this is bringing the attraction always away from solar thermal solutions. And there's no support scheme as such, you know, for having any kind of financial support for SMEs, you know, like small, medium-sized industries to look into SHIP. I have talked to some of the project developers, and they really tried hard to establish projects. And within Soltrain, some smaller projects were realized because they were subsidized, but it was not really getting a kind of momentum. Maybe Samson, you can add to that if you have additional insights.
Thank you, Bebo. Thank you for that. Yeah, definitely. Within the Soltrain project, it's been a target for us where we have the part in the last phase that we're basically Soltrain Plus, where we're having a drive directly in terms of industrial process heating with training around the different countries that we have done within Zimbabwe, South Africa, and Namibia. So it is definitely, as you've mentioned, that because of the price in terms of energy cost, it's not been having that great uptake. But I think there's been quite great interest. We had one company, I think this was early this year, where we went for a tour. They do cable manufacturing. So we're trying to make a mimic or benchmark with the application of a SHIP out there in copper mining applied in Zimbabwe. So definitely we're looking forward to some of the applications within our region in the next the next year.
Yeah.
Before, yeah. Thank you.
Thank you, Samson, and thank you, Pepper. I also think that the price of the oil, coal, etc. It's the main reason, maybe. Yeah. One question now to Valerie. This is let's say there's one question: why is Europe not so involved in this innovation system, looking at the largest market growth? So I think it's more on we see in some areas a market growth, and why is it not in Europe? I don't know if you have here some answers on this, Valerie.
I think we are just hoping that with all the positive legislation framework, the market will definitely, grow soon. We have, as I showed, different files: Renewable Energy Directive, Energy Efficiency Directive, EPBD. So there is clearly a strong policy signal from the European authorities towards the member states to now implement that package. They want to stay the course. Europe and our European leaders are really keen to stick to this Green Deal and Fit for 55 momentum, despite the geopolitical tensions, and even more because of the geopolitical tensions. We need to address the issues of energy security, Europe competitiveness, and be able to capitalize on the homegrown renewable technologies like solar heat. So it is indeed a moment of a difficult period. One politician was using the comparison of we are going through a winter, but hope that spring is coming. We need to keep calm and stay the course. So all these good projects, good legislative framework. I hear the question about solar PV for hot water, but why passing through electricity when we can produce hot water through solar thermal using 3 times less space on the rooftop? So there is clearly a no-regret solution, which is solar heat, which can work in a hybridized way with any other solution, and which can also share the rooftop smartly with the other technologies. So let's by all means embrace this technology for buildings, for also residential buildings, large applications, and district heating, which is clearly and solar heat for industrial processes. It's also, they need to have the right indicators and to really embrace and move. We have, I didn't say it, but there are good signals for an industrial decarbonization bank, which is being put in place here at EU level to really give access to technologies like ours. Solar heat is clearly highlighted in this decarbonization bank. So this should really hopefully help unlock some of the projects.
Yeah, maybe just to answer a little bit shorter, because we have that many questions and we have 4 minutes left. So to Valerie, maybe one question was: the most vacuum tubes for solar collectors come from China. How difficult and profitable would it be to manufacture them locally in any country? Do you have any idea on that?
My knowledge is that we have a lot of EU companies meeting 90% now of the EU demand. So I'm not up to date with the latest import-export figures, but we have also vacuum tube producers here in Europe. So I think they are really on the case to continue and have a progression of their growth. Yes.
Okay, yeah, good, thank you. To Samson, there's one question. In the thermosiphon system using evacuated tube, did you find a way to test for a failed heat pipe in the evacuated tube that looked fine and that looked fine?
Thank you for that question. Not quite. I think it will be quite an interesting issue to follow, as in terms of a failure, and obviously find some technical solutions to indicate. I know for general evacuated tubes, you can basically tell because of the change in shininess of the tube, whether it says lost its vacuum or not. But I think we're still yet to just get an establishment in terms of the failure of the heat pipe that may be inside. I think maybe I'll take it up as a follow-up in the project. Thank you.
Okay, thank you very much. There was just, Barbara just answered it in written form, but I would like to bring this in the discussion. It was about, can you provide any insights into why there are shifts back and forth between the heat purchase agreements versus EPC installs? You're muted, Barbara.
Yes, sorry. I think this is because the ESCO projects are always very large, and then they have a stronger influence on the market statistics. And so we sometimes see peaks in some years for ESCO, and this is linked to a large project that was coming online. So that is usually, it's a very simple formula which says large scale projects are usually installed or established as an ESCO.
Okay, thank you. Then to Monica, question, because there's, I think, twice and similar, why there's a reduction in the solar thermal system from 2000 to 2024. It increased and later reduced. Why?
Thank you very much for the question. So with regards to the accumulated systems in operation, we consider lifetimes. So for most of the countries, 25 years lifetime are considered. And as the installed, so the collector areas that have been installed 25 years ago are deducted, that means the decrease in that is the reason for the decrease in the operation in the system, in the collector areas in operation.
Okay, thank you. Yeah, and then maybe I don't know, a question to all of you. There's and I would like to combine it as what is the scope for innovation in solar thermal? What are the most pressing issues in the market? I don't know if who wants to answer this, and maybe also additional to this, there was one question. I will find it. Wind and infrared solar collectors. Do you see something happening in this with these collectors? I don't know if there's someone who can answer this question. Ever?
Well, what innovation is concerned, a clear trend from my survey was that cost reduction potential is still possible, especially in terms of looking at the whole supply chain, in materials, into installation, into planning phases, and there are still big cost saving potentials available, and a lot of innovation goes into this direction. And regarding the unglazed collectors, PVT collectors, I think they are always interlinked to heat pumps. And the major market, Monica, you can confirm that, is unglazed rest PVT collectors. And this is the major application at the moment in Europe, in the major markets like Germany. Germany was the largest PVT market last year in terms of new additions, and 90% of the systems in Germany are interlinked with heat pumps and are unglazed and open PVT systems.
Okay, thank you very much. Yeah, fine. I think all the other questions you either answered in written form, or we will answer it. Yeah, on that. So I think more or less, I think the most burning questions are answered on that. Yeah, fine. Thank you so much, everybody. I don't know, Arabella, will you have the last words of the
Yes,
webinar?
I will.
Okay, perfect. So I want to say thank you to all the presenters. It was great listening to you, and very interesting. And yeah, you see also on the questions a lot of interest in solar thermal markets. And yeah, thank you so much.
All right, a big thank you from my side as well. And I'm not going to take long for the last word. Yeah, once again, a big thank you to the speakers and for the presentations. I know that many of you have already been asking us about it. Yes, the webinar is being recorded just as we speak, and you will be given access to the recording once we have it, as well as the presentations that were given by the speakers. So you will be fully equipped to go back and revisit the presentations. And everything is going to be made available both on the IEA SHC Solar Academy homepage as well as on the ISIS homepage. For any ISIS members on the call, there is the ISIS membership benefit of the webinars archive, which you will know once you've logged into the members area. Last word from my side is that I want to raise attention to our conference, which is coming up this year, which is the ISIS Solar World Congress 2025. I mentioned it in the very beginning of the call. It's going to take place in November in Brazil, just in advance of COP30. Major event, obviously, for everybody looking to climate news. Yeah, registration for this one is going to open up quite soon. You will know about it. We will send you an email. So yeah, we are very much looking forward to meeting many of you there. And with that, it's a big thank you from my side. Thank you for joining us. Make sure to reach out if you've got any questions. You can reach out either to us or to the IEA SHC Secretariat, and we will answer all your questions. So yeah, thank you and stay in touch. Bye.